Wow. Good afternoon. Welcome to this special tutorial. Today we'll be looking at partial fraction. So under partial fraction, we need to recognize a rational function and also know how to decompose a rational function into partial fractions. So let's start. So the process of decomposing a rational function into simpler fraction is called partial fraction decomposition, and we do it by adding or subtracting the fractions. So first of all, we need to recognize a rational function. A rational function is a function. So if you have a rational function, it's just a function gotten by dividing a polynomial by another polynomial. So once you have polynomial over polynomial, we call it a rational function. For example, if you have 3 over x minus 2, this is a rational function. If you have x squared minus 3, x plus 2 over x minus 5. So these are rational functions. So the process of solving back, like assuming you have two fractions, maybe if you have, maybe we asked to find 2 over x minus 3 plus 4 over x minus 2. So if we are to solve this, the LCM is x minus 3 times x minus 2. So which is 2 times x minus 2 plus 4 times x minus 3. So after solving this, we have 2x plus 4x, 6x, minus 4, minus 12, minus 16. So the process of decomposing this to these two is called partial fraction decomposition. Like solving back to get the original fractions that when you added or subtracted to get this. So that's what we call partial fraction decomposition. So these ones are the partial fractions. These are the partial fractions. So why the process of doing that is partial fraction decomposition. So that's it. So in this case, since we have that a rational function is a polynomial over polynomial. So what we're going to see here is that the denominator plays a role in knowing how to decompose the partial fraction. So the first category of that is that when the denominator is a product of distinct linear factors. So if you have a rational function, so to decompose it, if you notice that the example, if you have something like this, if you have like 2 over x minus 3 times x plus 2. So if you notice, the denominator have two different linear factors. So how do you decompose it? We decompose it this way. So you split it into maybe any value, because we don't know the value, over s minus 3 plus b over x plus 2. So that's how we decompose it. So we'll solve, we'll compare the left and right side. That's how we solve. So that's the first category, when the denominator contains different linear factors. So why the second one is when that same linear factor, some are repeated. As you can see, we have ax plus b. Why this? We have as plus b squared. So if you have something like that, maybe if you have, we have to solve 4x over x minus 2 squared. So if you notice, this the linear factor x minus 2 is repeated. So how do you split this? We'll split it, we'll write the first one, that's raised to power 1 plus b, maybe, okay, let's use b, not raised to power 2. So to get to the highest power, like here, the highest power is n. So that's how you decompose it, that before we start solving. So that's the second category. The third one is when you have irreducible quadratic factors. Yes, if you notice that you can't factor the denominator, that is, if you notice that as squared plus bs plus c is not a perfect square, that is most cases when it's less than or equal to, that's when it's less than 0, not equal to. So when you notice that this quadratic factor is less than 0, we can factor it. So how do you decompose it? You decompose it with this way. As you can see, we have as squared plus bs plus c. So this is a second degree polynomial. What is up will be first degree polynomial. As you notice here, we have first degree polynomial. So the number here will be a 0 degree polynomial as a constant term. So that's how you decompose. Why the last category is when you have repeated irreducible quadratic factors. So when you now repeat, it's like the second one, when the linear factors are repeated. So in this case, we split it that same way. We splitted this, starting from 1 to the last power. But remember, whatever that must be on top must be linear. So you need to split it as something x plus a constant, meaning a linear factor. So the numerator is a linear factor, while the denominator is a quadratic factor. So that's it. So let's use question to solve. Like, let's now decompose questions. So the first one, as you can see, we are asked to decompose the following into partial fractions. So we have 4x over 2x squared plus 3x minus 2. So looking at this, you see that I can factor this denominator. Yes. So I can factor it as 2x minus 1 times x plus 2. Yes, so we can factor 2s squared plus 3s minus 2 to that. So this is now the first category. So let's now solve this. So this could be factored as 4x over 2x minus 1 times x plus 2. Okay, so we can decompose this as a over, remember I told you the denominator, 2x minus 1 plus maybe b over x plus 2. So because we have non-repeated denominators, as this case, as I showed you, have different cases. So non-repeated. So depending on the factor, I have only 2 factors, so I stopped at 2. So from here, we are now solving 4x over 2x minus 1 x plus 2 equal to a over 2x minus 1 plus b over x plus 2. So if you multiply left and right hand side by the denominator, that's 2x minus 1 times that, we are left with 4x here. While here we are left with a times x plus 2 plus b times 2x minus 1. So to solve this, we need to be logical, since we have 2 unknown and 1 equation. We can't use simultaneous, so we now use logic. So if I say let x to be equal to minus 2, so by doing so I will cancel out a, so I will eliminate a. We can now solve for b. After, we can still substitute x as half and eliminate b. I solve for a. So let's solve for b. So I've substituted x as minus 2. I have 4 times minus 2 equals, this is 0. So if you substitute this, 0. So I have b times 2 times minus 2 minus 1. So I have minus 8 equals this minus 5b. Solving for b, we have that b is 8 over 5. So we've gotten the value of b. So let's get for a. So how do you do it? We substitute, let x equal to half. So we have that 4 times half equals a half plus 2. A times half plus 2. Why the remaining is 0? Yes, because 1 minus 1 is 0. So I have 2 and a half, which is 5 over 2a. Y here is 2. So solving for a, we have that a is 4 over 5. Since we've known the values of a and b, we now go back. Therefore, this original expression could be decomposed to a is 4 over 5. So I have 4 over 5 times 2x minus 1 plus b is 8 over 5. That is 8 over 5 times x plus 2. So this is it. So that's the partial fraction decomposition of this.